Good morning, everyone. Welcome to the class of CE331, Environmental Engineering 1. So, last day we were discussing iron, manganese, and arsenic removal, right? And then we discussed iron, manganese, and arsenic removal. And then we discussed desalination. And in the process of desalination, we were discussing electrodialysis and this process, and then reverse osmosis. Okay, now let's talk about activated carbon application. So this name is activated carbon. Activated, it's a carbon, but activated carbon. What is this? Refractory organic can be removed from water by adsorption process. Refractory means uh, which are difficult to remove. Okay, the refractory organic can be removed from water by adsorption process. Adsorption can be defined as the accumulation of substances at the interface between two phases, liquid or solid surface. The adsorbent most commonly used as activated carbon. Adsorbent means who can adsorb. So, um, we discussed previously that adsorption is a process. Adsorption is a process where this is a material. Here, there is very small materials like this.
Sir,
Yes, go ahead.
sir ilişkin bir daha çalsın.
Oh, can you see this now?
Yes, sir.
Sir,
Yes, sir.
this or this.
So, I was saying that in the process of adsorption, we have a material here, and we have other materials here. What is adsorption? Adsorption means this material will get attached with this material like this. Okay, so they are in contact and attached. This is adsorption. That means the surface of this material and this material will be connected. Okay, will be attached actually, so we call it adsorption. Now, this in this process you can remove very small particle from water. Even bacteria and virus can be removed sometimes. Now, higher is the adsorption. This material is called adsorbent. Who adsorb others. Now, higher is the adsorption capacity of this material. Higher is the adsorption capacity of this material. Higher is the removal, right? Higher is the removal. So your objective is to increase the adsorption capacity of this material. How we can do this? If you take a piece of wood, for example, organic matter, a piece of wood, okay? You take a piece of wood and then you burn it. You burn it in high heat. Okay, then what would happen? This wood has several volatile organic matter here. Okay, so they will burn out, and you'll see there are different pores. Pore, pore. These are pores. Okay, due to burning of the wood, you'll see that there is hole or pore inside of it. That means this material has gone out. So you can see a hole or pore. These are volatile organic matter. Volatile organic matter which has gone out. Okay. Now this is actually a skeleton, right? This is basically a skeleton of the wood after burning. Now if you then pass this burned wood, if you then pass it through certain environmental condition with passing gas there, then this material becomes activated. What is meant by activated? Activated means that this material is now with more efficiency and capacity to absorb material. That means it has higher adsorption capacity. Higher adsorption capacity. That means you can increase the adsorption capacity of this material by the successive burning and then eventually passing it through the certain environmental condition. Okay, so now this material, since this has higher absorption capacity, it can absorb smaller particles with larger capacity. Okay, so this material is called activated carbon. Why carbon? Because this is wood. This is made of what? Organic matter, carbon, hydrogen, and then you burn them. That means you broke the chain, and what is remaining? This is basically carbon, right? So coal-like matter, coal. So activated carbon. Okay. So activated carbon can be prepared from virtually any organic solid, coal, lignite, wood, to pass through a destructive distillation process which drives off the volatile or components of the material, leaving behind a porous carbon skeleton. A porous, that's what we are talking about, porous carbon skeleton, which has very large surface area per unit volume. Why large surface area? Because now it has many pores, right? So unlike the solid one, before burning, unlike the solid one, since now it has many pores, that means yes, surface area has increased drastically. This skeleton is then activated by steam in an oxygen depleted atmosphere. So you pass this through steam. in an oxygen depleted atmosphere at temperature ranging from 750 to 950 degrees Celsius. This is very high temperature, often with the addition of dehydrating agents like zinc chloride or phosphoric chloride. Then you get activated carbon. Okay. Now, what's the theory behind this? Why it can absorb material matters. Molecules in solution are attracted to and may be held by a surface in contact with the solution. Who, what helps these materials to get absorbed onto this? Van der Waals force. Okay, what helps them to get absorbed and get connected? This is Van der Waals force. Van der Waals force. The forces holding adsorbed molecule to the surface may result from either chemical bonding or van der Waals force. So it can sometimes it can also be chemical bonding or chemical bonding, van der Waals force or chemical bonding. Okay. Absorption will remove gases, liquids, and solid from solution. Okay. Uh, in your house, do you use filter media to get clear water for drinking? Filter. Do you have this in your house?
Yes, sir.
In that filter, you'll see there is a compound like this. Did you ever change it?
Yes, sir.
Shape may vary sometimes. And you'll see this material is black and there has many pores. This is actually activated carbon. This is activated carbon. Okay. So factors which affect the adsorption capacity, factors which can affect the adsorption capacity of this activated carbon. This is very important to know. Adsorption is greatest at low pH. So if your pH is low, then adsorption will be higher. High temperature, then again adsorption will be higher if the temperature is high. Absorption is higher if the pH is low. Adsorption is higher if the temperature is high. Again, adsorption is higher um, if the concentration increases. Concentration of pollutants. If the water has higher amount of pollutants, then the adsorption will also be much higher, the rate of adsorption. But adsorption will be low if the molecular size is higher. So if the particle size here is much larger, then adsorption will be low. Then molecular weight and complexity of molecular structure. Application: activated carbon is used in water treatment in the form of both powder and granules. It can also be used sometimes in powdered form and sometimes in granular form. So I just told you that in your household water treatment process, you also use sometimes this activated carbon. Majority of the time, not sometimes. Granular activated carbon has effective size of the zero point 0.1 to 2 millimeter inch diameter, and powder activated carbon is generally less than 0.075 millimeter in size. So that can be used both in granular, that means granular form is that where the size is much larger, activated carbons, size larger like this, and this is granular, and in powder form these are very small activated carbon. So granular activated carbon and powdered activated carbon. Okay, is it clear, guys? Is it clear?
Yes, sir.
Yes,
Okay,
sir.
so here it ends. Here the water treatment topic ends. So today we will move to a new topic. Let's see. Topics. Climate change. So you have heard many times about climate change, right? This is an this is a burning environmental issue that we all need to address uh, if we want to survive in the long run in this world. We all need to address this, and it's incredibly important to know what is climate change and how does it work, okay, and how our life is being affected by this climate change. So if you want to know the climate change and global warming, you need to know what is greenhouse. Okay, so what is greenhouse? About greenhouse, you already know that in the region where most of the time it is winter, in those places you it's difficult to grow the plants. Therefore, you make a glass, you make a house of glass. You make a house of glass, and then inside of it you plant trees. What happens that when sun rays come first time, this is hot, right? So it goes through the glass, it passes through the glass, and since they have higher temperature, their wavelength is much smaller, so they can enter, and heat is absorbed. Now, when it cools down, then this radiated energy has much higher length now. Wavelength is now much higher, and now since the wavelength is higher, they cannot pass through the glass. This direction possible because the wavelength was smaller, so it can pass through the glass. But this direction flow outwards of the radiation is not possible because now it is cooler and therefore the wavelength is much higher. So what happens that therefore since the radiation is getting inside of the glass house but cannot go out, therefore the temperature of this house glass house increases. Okay, now since we can plant trees inside of this, so we can call it green because we plant here, right? Greenhouse. So there's the concept. So what's the concept? That greenhouse can keep the surrounding or ambient temperature higher. Okay, even though you have cold outside of the house, but inside of the house it is warmer. That's greenhouse. Okay. Now let's see. This is, by the way, this is man-made, right? This is man-made. In nature, exactly same thing happen. Okay. So let's see what happens. Life on Earth depends on the energy coming from the sun. About half the light reaching Earth's atmosphere passes through the air and clouds to the surface, where it is absorbed and then radiated upward in the form of infrared heat. So, a layer of greenhouse gases, primarily water vapor, including much smaller amount of carbon dioxide, methane, and nitrous oxide, acts as a thermal blanket for the Earth, absorbing heat and warming the surface to a life-supporting average of 59 or 50 degree Fahrenheit or 15 degrees Celsius. About 90% of this heat is then absorbed by the greenhouse gases and radiated back towards the surface, which is warmed to a life supporting what I have already told you. So what happens that this is our Earth and this is the sun. Okay, so here is the sun. Now it's radiating heat energy, and this heat comes to the Earth's surface and then sometimes reflected back, right? Reflected back. Now, what you have here is a layer of gas, a layer of gas, which has a multitude of components. Especially, we have water vapor, we have carbon dioxide, we have methane, okay, and sometimes nitrous oxide. Now, this layer of gas functions the same way as this glass functions. How? This heat, which is radiated back, they cannot pass through the blanket. They can move in this direction, that's okay, but when they try to get past there, this direction, that's not possible because now they have much larger wavelength and they cannot pass this layer of gases. That means which makes or keeps the earth warm to a temperature of approximately global average 15 degrees Celsius. And guess what? That's the temperature, average temperature that we need to survive in this earth. If this blanket was not here, then majority of the heat would have passed through the space, and then the earth temperature would have been much lower, even maybe negative. Then human being would not survive in this earth. So we need this to keep our earth uh, at a comfortable temperature at which we can survive. Okay, so that's natural. Okay, that's natural. Where is the now what is the problem? The problem is, again, these are natural. Okay, now the problem is Since the industrialization, first and second industrialization, especially in 17th and 18th century, 17th century and 18th century of industrialization, we have industrialization. Due to industrialization, human beings started using fossil fuel a lot. And when you burn, these are basically organic matter. So when you burn this fossil fuel in your car, in your industry, in your machines, then they emit carbon dioxide and other gases. If you burn them, they emit carbon dioxide. Okay. Now this was natural, but you are now adding a massive amount of carbon dioxide. This is artificial. Artificial means you have generated it by burning fossil fuel and other activities. So now you are adding carbon dioxide here. Man-made. Okay, this is anthropogenic. So adding much more carbon dioxide here. So therefore, this blanket is thicker and denser. Therefore, more and more heat is entrapped. More and more heat is entrapped, and which eventually increase the Earth's temperature further than that what is required. We needed a temperature, a warmer Earth. That's okay, but now you are you are emitting more and more amount of carbon dioxide and these gases and other gases, which increase the thickness of this layer, this blanket, as well as the density of this layer, and therefore more and more heat is entrapped in the earth, which eventually increase the temperature of the earth. That's called global warming. By the way, global warming was a natural phenomenon. First of all, you need global warming, right? Global warming was a natural phenomenon, but now we are adding more greenhouse gases to increase the Earth's temperature beyond the capacity of beyond the range than that what is required for a sustainable Earth. Okay, so global warming. Most climate scientists agree the main cause of current global warming is the trend human expansion of the greenhouse effect. Certain where is this here global warming. So this is natural warming. One was natural, as I told you, which is important. By the way, this natural warming is important for us to survive. Now, since we are using more and more fossil fuel and other um, activities which emits greenhouse gases, now we are amplifying. Amplifying means that we are increasing, we are accelerating this warming process, which is dangerous. The amplified warming. One is natural warming, which is important, and one is amplified warming by human being, which is dangerous. This is uh, harmful. Okay, so read these things. These are uh, the text which I have just mentioned a while ago. So the greenhouse effect is a natural phenomena and that is essential to keeping the Earth's surface warm. Like a greenhouse window, greenhouse gas allows sunlight to enter and then prevent heat from leaving the atmosphere. These gases include carbon dioxide, methane, nitrous oxide, and water vapor. These gases are called greenhouse gas. These gases are called greenhouse gas. These gases are called greenhouse gas. Greenhouse gas. Okay. Human activities, especially burning of fossil fuel, are increasing the concentration of many of these gases, amplifying the natural greenhouse effect. So when you amplify the natural greenhouse gas effect, then this is dangerous. Global warming. The climate scientists agree the main cause of the current global warming is human expansion of greenhouse effect. Warming that results when the atmosphere traps heat radiating from Earth towards space. Certain gases in the atmosphere block heat from escaping. Long-lived gases that remain semi-permanently in the atmosphere and do not respond physically or chemically to changes in temperature are described as forcing climate change. Are you following me, guys?
Yes, sir.
And gases such as water vapor, which respond physically or chemically to changes in temperature, they are seen as feedback. So there are two terminology. One is forcing, and another is feedback. Okay. Um, let's take an example here. This is Earth. This is the atmosphere we have here. Gas, right? This is the gas layer. Yeah. And this is the Earth. Oh, you have H2O, water vapor, then carbon dioxide, nitrous oxide, and methane. Okay, these are and others. You have other gas, nitrogen. In atmosphere, you have many other gases, nitrogen, oxygen. Okay, but we are talking about these gases which can entrap the heat. Okay, there are other oxygen in the there are other gases in the atmosphere. We're not talking about them like oxygen, nitrogen, and others. We are talking about the gases who are responsible to entrap the heat. Okay, so don't get confused or misled with a feeling that we only have these gases in the atmosphere. We have other gases, but we are interested only about them because they are the greenhouse gases. Okay, now here, um, for example, you are generating H2O. You are generating H2O vapor. I mean, you have a pond here. You have a pond here, and due to the sunlight, heat, the water is evaporating. The water is evaporating, so it is added here H2O. Now, what happens that although you have added new H2O here, this H2O can easily be transformed, condensed, and make cloud, and then they can come again to this pond or any other surface water. So what's the process? You have water body any like pond, lake, and due to the sunlight, this water can evaporate. Some portion of the water can evaporate it, and they come to the atmosphere, right? And this H2O can easily be transferred to rain. So it can change physically, easily and promptly. So this H2O does not impact the overall blanket of these gases, because whatever additional H2O had come, they return to the earth. Am I right? But what happens to carbon dioxide? If you generate carbon dioxide, if you generate, oh, by the way, before I go there, this H2O is not present now because this H2O has returned back to the to the earth. Now, what about the carbon dioxide? When you burn fossil fuel, like from your car or your industry, when you, for example, it's a brick chimney, so carbon dioxide, then this carbon dioxide is added here, and this carbon dioxide is not temporary. It lasts long in this layer. They are not converted. Unlike H2O, they don't convert to other forms easily. That means they are actually contributing to thicken the blanket of this gas, and they are gonna remain there for a long time. That is actually uh, contribute. Therefore, it is actually contributing to the amplified warming. So since H2O is going there and coming back, H2O, this is feedback. This is called feedback, and feedback is not harmful much. Feedback is not much harmful towards the global warming. But carbon dioxide is going there, but it's not coming back easily. It's not coming back easily. So it's called forcing. For carbon dioxide, it's called forcing, which is actually contributing to amplified global warming. Are you following me?
Yes, sir.
Yes, sir.
So in terms of global warming, feedback is not that bad, but this forcing, this is bad, because the gas is coming and it's not going out easily. It's gonna stay here for a long time. Okay, that is gonna contribute to your amplified global warming, and that is actually harmful for us. That is actually harmful for us. Okay, so feedback is not that bad actually, but forcing, that's the problem. Long lived gases remain semi-permanently in the atmosphere and do not respond physically or chemically to changes in temperature and are described as forcing. Okay, so if I simplify it again, this is the earth, H2O came here, okay, and this H2O is contributing to uh, amplified warming. But with amplified warming, there is cloud formation with this H2O, and then you have rain. So due to this rain, the temperature is again decreasing. So once this H2O increase the temperature, now this H2O is decreasing the temperature and coming back. So this is feedback. But carbon dioxide, once it comes there, it remains there. It does not change its form like H2O. With higher temperature, the carbon dioxide goes there, it increases the temperature, and with increasing temperature, it doesn't change its physical or chemical form. More carbon dioxide, more increased temperature, but it does not come back. More carbon dioxide, more increased temperature. Is it clear? This is called forcing. This is bad. And this is called feedback. This is not that bad. Clear? So let's look about the greenhouse gases. Look at the greenhouse gases. The major greenhouse gases in our environment is water vapor, carbon dioxide, methane, nitrous oxide, and chlorofluorocarbons. So water vapor is as I told you, it's a feedback mechanism. So we are not worried about water vapor a lot. Okay. So the most abundant greenhouse gas, but importantly, it acts as a feedback to the climate. Water vapor increases as the Earth's atmosphere warms, but so does the possibility of the cloud and the precipitation. Make these some of the most important feedback mechanisms to the greenhouse gas. So water vapor, we are not concerned about it. Okay, the problem is carbon dioxide. The main problem is here, this carbon dioxide. This is the major problem. And then methane, nitrous oxide, chlorofluorocarbon. So carbon dioxide is a minor but very important component of the atmosphere. Carbon dioxide is released through natural processes such as respiration, volcanic eruption, and through human activities such as deforestation and land use change and burning of fossil fuel. This is a very crucial source for carbon dioxide. So this is important for you to know. This is important for you to know these greenhouse gases and their sources. So uh, we are focusing here mainly on the sources of greenhouse gases. For example, for carbon dioxide, the sources are is respiration. Respiration means, for example, as a human being, you take oxygen, but you give back what? Carbon dioxide. So that's respiration, right? This is the process of respiration, and you can see this process of through this process of respiration, you emit carbon dioxide. Okay, so through human activities such as deforestation, then if you have much larger plants do exactly the opposite. Plants in the process of photosynthesis, plant take carbon dioxide and then emits oxygen, which is good. So plant is actually helping to reduce the temperature. Now if you cut down the trees, then this process which is beneficial to us is just stopped. Then burning of fossil fuel, as I told you, like in your car, or you emit the backside, right? So you emit carbon dioxide because you're burning oil, fossil fuel. In your industry, like big brick chimney, okay, you are emitting carbon dioxide, okay, and so on. So nowadays you see that everywhere green technology, green. Whenever something says green, that means that's sustainable. That means it emits lower carbon dioxide or does not emit carbon dioxide. Okay. So when you have a green building, guys, when you have a green building, I mean, someone tells you this building is green. Does it mean that it has green color? Huh? Hello?
No, sir.
Doesn't. I mean, yeah, sometimes may refer a green building as a green color, but technically, if someone tells us, okay, this building is green, that means it emits low carbon dioxide. It emits low carbon dioxide. That means this is green. If a machine or a technology is green, let's not use the green color here. That will be confusing. Uh, if a machine is green, that means which emits low carbon dioxide. Okay, low carbon dioxide. And nowadays you will hear that everywhere uh, there is a slogan to use green technology. So the purpose is to emit low carbon dioxide as low as possible. Okay, to emit carbon dioxide as low as possible. And sometimes government even give you some extra concession or discount if you use these green technologies. For example, an example of green technology is renewable energy, like like solar power. Solar power. It does not emit any carbon dioxide. Okay, but solar power is expensive. There are many other issues. It needs a large amount of area. Okay, there are issues of availability of sunlight. Okay, so there are some issues, but solar power, the main objective of using solar power is to reduce carbon dioxide emission. Okay, so this is called renewable energy. Okay, renewable energy. What? Why renewable? Because they are abundant of solar energy. They are abundant of solar energy. So um, and that emits less carbon dioxide. Okay, so renewable, renewable. This is not limited that much. Okay, but in case of fossil fuel, like fossil fuel, where do you get this from? You get this from the earth storage inside the earth, right? And these are limited fossil fuel. The carbon dioxide which were entrapped in the earth's soil for millions of years, not carbon dioxide, in form of carbon hydrogen chain, fossil fuel, right? These are fossil fuels. This is carbon hydrogen chain, fossil fuel. You, this fossil fuel which was entrapped in the earth for millions of years, now you are extracting them and using them in your car, in your industry, and you're releasing this carbon dioxide into the atmosphere. The carbon dioxide, remember, this carbon was entrapped in the earth surface. Now you're emitting this carbon. You're emitting this carbon to the atmosphere. So this extra amount of carbon will amplify the global warming process. Okay, and that's why we call it non-renewable energy source, because this carbon dioxide to get inside here, you may take million and billions of years inside of the earth. Okay, So that's non-renewable fossil fuel, non-renewable, and this is renewable. Okay, and also like wind energy. Wind, you see there are different blade here, and with wind it moves, right? It moves, and that rotates a turbine, and that generates electricity. So this process also does not need does not emit carbon dioxide. But if you use a generator which use diesel, this diesel is also what? Fossil fuel that emits carbon dioxide. Okay, so this is a renewable energy source. This windmill, right? We call it windmill. This windmill is a renewable energy source of power. Okay, then hydropower. If you have a falls here, okay, falls. If you have a falls, you know falls, right? I mean, water is falling from here. Then you can install a turbine, and this water force will rotate the turbine and generate electricity. So that's also a renewable energy source which does not emit carbon dioxide. Okay, so these are basically green technology. This is a green technology. This is a green technology, and solar power is a green technology. Is it clear?
Yes, sir.
This is incredibly important to know these things because um, in the long run, in near future, many of you will be working in industry and um, give your own business firm, inventing something. So doesn't matter where what you are doing and where you are working on, you need to keep these things into consideration because in near future every country, almost all of the country, in all of the countries, government will um, slowly move towards these technologies and will try to impose rules and regulation which will tell you to which will enforce you uh, to use green technology. For example, if you had a brick kiln, if you had an industry of brick, okay, where you have brick kiln, now government is gonna ban them because they emit carbon dioxide. Bangladesh government is gonna ban these technologies. So if you're thinking about investing in these types of technologies which produce a massive amount of carbon dioxide, you better should not invest in these things because in near future there may be banning order coming from the government. Okay, and then you will incur losses. So from now on, whatever you use, think about the green technologies, green process, which encourage you to reduce carbon emission. We call it carbon emission. For example, use less plastic. That's a slogan nowadays. Use less plastic because plastic formation and these things produces carbon. And also, plastic has other problem like it clogs our sewer system. Okay, and also the plastic particles the can produce microplastic, and which can goes to water body, which is harmful for the aquatic environment. Okay, so as a human being, if you want to survive in this earth, we need to think about these issues. Now, where were we? Yeah, so similarly, carbon dioxide, we had methane. The source is waste, landfill, agriculture, rice cultivation, and these things. There's nitrous oxide. What is the source? The source of nitrous oxide is also soil cultivation process, commercial and organic fertilizers, fossil fuel combustion, and chlorofluorocarbon. Chlorofluorocarbon is a synthetic compound, CFC, which was used to make refrigerator. But since this is a um, greenhouse gas, majority of the government in the world has banned CFC, chlorofluorocarbon, nowadays to um, produce this. Okay, so this is now banned in majority of the countries. CFC is banned. So fossil fuel burning, I already told this thing that over the last century, the burning of fossil fuel like coal and oil has increased the concentration of the atmospheric carbon dioxide. This happens because of the coal or oil burning process combined with carbon with oxygen to make carbon dioxide. Okay. Now climate change. We are talking about climate. We are talking about global warming and amplified global warming, and we are talking about a multitude of uh, process through which we can reduce the carbon dioxide emission. Now, why? What this global warming is gonna do to us? What this global warming is gonna do to us? Why we are afraid of this? That's the question. So let's learn what is climate. There are there are differences between climate and weather. Climate and Do you know the difference?
No, sir.
Huh? Do you know the difference?
Yes, sir.
Okay, that's great. So can you please tell me what the difference?
স্যার ক্লাইমেট হচ্ছে স্যার অনেক বছরের একটা মানে ওয়েদারের রেজাল্ট, আর ওয়েদার তো স্যার কয়েক দিনের।
Exactly. So this is the long term, and this is short term. Climate, when you refer to climate, you refer to long term trend, and we refer to weather, that's the short term condition. For example, in Bangladesh, for example, in winter, for example, in December and January, December and January, we can tell that the temperature will be low, right? Because we have winter in this time. How could you know this thing, by the way? That in January and December there will be low temperature? Because you know that the environmental process through the environmental process and weather the um, atmospheric process and by the data of last 100 years. If you take the data of last 100 years or maybe 200 years, you'll see that yes, in January and December the temperature is typically low. This is winter. Now let's talk about weather. if I tell you, okay, now this is summer and the rest of the दिन is summer, right? And you from this is winter and you have summer. You have summer. Rest of the months. You have the summer. Now we are in summer right now, for example. Now if I tell you that um, in summer, for example, in August 20 today, right? And August 25. So if I want to know the condition of the atmosphere or environment, what terminology I will use? If I tell you that what is the environmental condition today about the atmosphere, would I say that what is the climate at August 20, or what is the weather at August 20, or what is the weather at August 25? Which term do you want to use, climate or weather? You're gonna use weather, because this weather can vary from day to day. In August 20, this may be sunny and hot. In August 25, it can be rainy, or it can be rainier and gloomy and cooler. Am I right?
Yes, sir.
So this weather can vary from day to day. Even August 20 can be sunny and dry. If August 21, the next day, that's the just next day, it can be rainy and cool. So it can vary a lot. So weather is short-term phenomenon and climate is long-term phenomenon. So when you refer to something climate, that means we are referring to something long-term. Okay, 30, 40, 50 years of data. So when I tell climate change, when I tell you that climate change, that means this is the long-term change. This is the long-term change. For example, um, for example, in today, this is 2020, right? And this is the year 2020. For example, this is a month. This is what, August, right? August. So an average temperature. Here, average temperature of August means August 1 to 30 or 31st. This 30-day average temperature. Okay. Similarly, you take the average temperature of 2021. Similarly, you take the average temperature of 2022. Okay. Are you following me? So from this year only August, from the next year only August, from the next year only August. So you are taking only August, for example, and 2023. Okay. Now, if you see the temperature here, like average temperature was 28 degrees Celsius, and this is 29 degrees Celsius, and this is 29.5 degrees Celsius. This is again 27 degrees Celsius. So if you plot this, uh, 2020, then 2021, then 2022, and then 2023, you'll see that this is fluctuating, and then our decreasing. So this is kind of like this. This is from this year to this year to this year. The temperature is changing. Okay. Now, if I plot this for uh, maybe 2070 up to 2070, you'll see that this is fluctuating like this. So, in an average, this is not changing much. Okay. Yes, there are short-term changes like this to this, again this change, again this change, this change. Okay, this is short-term changes. But if you take about 50 to 40 years or 30 years data, you'll see that this is not changing much. Am I right?
Yes.
But but if you plot this for 50 years from 2020 to 2070, right? And 2070, if you take the data and you'll see this, then you can clearly see there is an increasing trend. Am I right?
Yes, sir.
Again, we are not considering about the small yearly 1 year to another year change. No, this consecutive year change, no, we are not thinking about it. We are thinking about this long term from 50 years of data, 2020 to 2070, 50 years of data. Now we can see there is a trend, it's increasing. This is temperature, this is temperature in this direction. This is called climate change because this is long term change. That means there is something wrong in the temperature. This is consistently increasing for the last 50 years. This is called climate change. This is not climate change. This is just consecutive year change temperature. This is not climate change. What is climate change? This is climate change. Is it clear?
Yes, sir.
Yes, sir.
So if you look, the fossil fuel emission is increasing from 1960 to 2010. In the last 50 years, fossil fuel emission is increasing. And there we are talking about the process where um, the earth, from earth carbon dioxide is releasing. There are some other process through which the carbon dioxide from the atmosphere can come to the earth. How? Tell me how. For example, you have a plant, this can take carbon dioxide, and this can take carbon dioxide, and this carbon remains in the body of the plant, and then when this plant die, it goes to the earth and is buried under the soil. So carbon is getting inside of it. So this is a sink. This is what called sink. That means carbon is going into the earth, and this is carbon is going out of the earth. This is source. Sink and source in terms of the atmosphere. If it comes to the atmosphere, this is source. If it goes out from the atmosphere, this is sink. Clear? So if there is source, this process, this will increase the temperature and this will decrease the temperature. Okay. So load sink, there can be many sinks over there. Okay. And plus minus, if you do this, you'll see that there is a net positive, that means source. There is a source is net positive, that means in net term, if you balance out the plus minus, then overall the carbon dioxide is increasing in the world, increasing. Okay. And if you see evidence temperature anomaly, if you take from 1880 to 2000, this 20 years of data, you'll see that the temperature, annual temperature is increasing, average temperature. Okay, average temperature of Earth is increasing. Now, why we are afraid of this global warming, amplified global warming? Why? Because these are gonna have a catastrophic. These are gonna have a catastrophic impact in the world. Okay, so consequences can be very dangerous. If you have global warming, amplified global warming, there will be hurricane, there will be cyclone, with greater intensity and strength. So that means that the strength of the natural disaster like hurricane and cyclone, that will increase in strength if the global warming is on the process, and the um, frequency of this disaster will also increase. That means previously, if there were 10 cyclones or hurricanes in a year per year, now there will be 20 hurricanes per year. And not only that, the strength of this each of the hurricane will be increased. These are supported by the data. These are not fluke. Scientists have shown that nowadays the number of hurricanes and this natural disaster in a year has increased than the previous years. And not only that, their intensity, that means the strength, has also increased. That means they have boosted their strength. Okay, so this global warming has bolstered the strength of this natural disaster, and higher is the strength, higher is the strength of this natural disaster, larger is the destruction, right? um, is more destructive. Greater the strength of this hurricane, the more destructive they are. Okay. Not only that, in the northern pole, you have massive volume of this ice, right? You have massive volume of this ice, and sometimes this ice is larger than Bangladesh. A chunk of ice can be larger than Bangladesh or maybe many more other continents. Now, if they melt down with this global warming, from the satellite data, you can see that from the last 50 years from now on, you can see that there is a gap in the North Pole. That means those ice has been vanished. That means they have melted down. And as they melt down, then what happens? The sea level will rise. And in for the low-lying countries like Bangladesh, if you see, this is the map of Bangladesh, for example, you have Bay of Bengal here. So this sea level will rise and it will inundate many southern part of Bangladesh, many areas located southern part of Bangladesh. Okay, not only that, you have salinity here, right? Remember, you have salinity. So this salinity will intrude into the inland water, and that will hamper your irrigation as well as your drinking water. So everything is gonna change in this location, and that's also gonna impact the whole country. Okay, because hurricane and these things are coming, cyclone and these things. So global warming um, can have massive destructive effect and massive destruction. So that's why we are trying hard to reduce this carbon emission. Okay. So whatever This I like this figure because in a nutshell, it tells us the whole process how the greenhouse gas is formed from different sources and what is the effect of these greenhouse gases. Okay, how it hampers and harms our environment, how it amplifies the global warming process, and therefore it harms the whole world. One more thing I just want to say, you know, this global warming, greenhouse gas emission process, the one single country cannot tackle with this. So therefore, you need the whole world. All the nations should come together, okay, and work together to tackle this greenhouse gas problem. I mean, global warming problem. Okay, only one single country cannot tackle this. So this is a global phenomena. So, any questions, guys? Any questions?
No, sir.
No questions. Okay, then if you don't have any questions, then what's going on? Yeah, I got it. So tell me who is missing here. Is there anyone who is missing in this column? Is anyone missing? Those who are not present in column A, that means those guys are late. Anyway, so tell me who is missing here. No missing. Okay then. I want to end the lecture here. Thank you very much, guys, for attending the class. Have a good one and stay safe.